Today we will make the robot move. Use sensors to make adjustments while in transit to make sure that it will be able to follow the line or navigation path. I will also show you how to create functions to better organize your code. We will use pins 1 and 8 to control the left motor, pins 2 and 9 to control the right motor. Set the pull of all pins to none. We will set the pull of each pin later. Changing the pull of signal of a pin will affect the motor speed and direction rotation. You learned in an earlier demonstration that setting the pull of the pins to none or 0 will stop the motors, as shown. You need 4 lines of code to stop the motors. You will need the same set of code every time you want the motors to stop. Instead of doing this, we will create a function to organize and make your code reusable. I will name this function stop, since its purpose is to stop the motors. Move the lines of code inside the stop function. This time, you can use the same code when needed by calling its name anywhere. Make a duplicate of the function stop and rename it as forward. We will make the forward function flexible by making it accept a parameter. Edit the function so that it will accept a numeric parameter. Name the variable as power, since it will be used to indicate the amount of power that will be sent to the motors. The variable power will store the numeric value that is included whenever the function is called. This way, the value of power will be flexible whenever the function is called. Make a duplicate of the function forward and rename it as reverse. Modify the code so that the motors will run in reverse. Remember that pins 8 and 9 are not PWM pins. We can only set them as either 0 or 1. You can edit the function and remove the parameter, since it has no use. Create 2 more functions, one for turning left and one for turning right. Make the left wheel rotate in reverse for the robot to turn or rotate left. Make the right wheel rotate in reverse for the robot to turn or rotate right. You may modify the code as needed. We now have the motor functions that we need: stop, forward, reverse, left, and right. We can now proceed to part where we tell the robot how to follow the line. We will use a black tape on a light surface. The idea is to make sure that the robot knows where the line is almost all the time, meaning It will always check the position of the line every time. We will use the two line trackers, or infrared sensors, to check where the line is. The sensor will send one if the black line is detected. That is, when there is not enough reflection received because the sensor is on a dark surface. We will make the robot perform adjustments by turning left or right whenever the sensors see the line. Checking is done every time the robot moves forward, making sure that it is on track. Set the pull of pins 13 and 14. These pins are connected to the line trackers based on the recommended wiring connections. Let us make the robot move forward using 1/8 power of 5 volts, which is equal to 0.6 to 5 volts. It is safer to test the code using less power. You may change the value if you want to send more power to the motors later. We will use a loop to make sure that the robot will continue adjusting by turning left or right, as long as the sensor reading is 1. Do the same for the other sensor. Upload the code and test. Can you make the robot move faster without losing the line? Can you? Anyway, enjoy!